So let's go ahead and do week 2, question 9. So I'm pretty sure when it comes to this is a little bit advanced, but I think some of you guys can handle it. So it basically is talking about this is an expression, and we can rewrite expressions in different ways. So one of these ways can also be rewritten and they can kind of match. So that's what it's talking about. So whenever you see a number like this, and it's outside of some stuff happening with parentheses, I want you just to think distributive property in your head. That is the distributive property right there. So in the distributive property, this means that this 3 is getting distributed to everything in here, and distributed to means to multiply. Okay, so we have 3 times n, which is 3n, plus 3 times 6, which is 18. So we can easily see this one is definitely the same thing. It's just rewritten. So let's go through there. Whenever you see all that apply, I guarantee you there's at least 2. All right, so let's go ahead and look at this first one. It looks like it could. This is 3 distributed to the n does give me 3n. But then I still have that 6, and that's not how the distributive property works. It has to be distributed to all. So in this case, it didn't get distributed to the 6, so it cannot be A. C, I'm not even sure where they're getting that we have these 2 n's. So what this looks like is basically we have some like terms in here that are not being added together. So for example, we have 2 n's right here, and we have another one here. And you just kind of have to look at it and be like, I don't understand why they're separating. If we have 2 n's and then another one, well, in total, we have 3 n's. That makes sense. And then on the other side, we have this 4 and this 2. Okay, so if they are just numbers chilling, why couldn't we just do 2 plus 4 and combine them? And that would be 6. Now, once again, that is going to show you that this is not right. So it can't, because we already determined that 3n plus 6 wasn't it. Now this last one I know is going to be a right answer, because when it says all that apply, I know there are 2 answers. But let me show you why. We are going to distribute, we're going to combine it. This is a multi-step problem. Again, it's pretty advanced. So if it doesn't make sense, just, kind of check it off and you can go on to question 10. So we have 4 times n, and then we have to distribute the 4 to the 6. 4 times n is 4n. 4 times 6 is 24. Now we have this minus sign, and this minus sign actually gets distributed to everything as well. So it turns it into negative n and negative 6. Again, I haven't taught you this. So I'm going to combine some like terms here. I know that 24 and negative 6 are just numbers. And I know that 4n and negative n are my little n's. So if I have 4n and I take away 1, that's 3. 24 and I take away 6, that's 18. So this is the same thing. It just looks a little crazy. But again, if you're not comfortable with this and you understand this portion of it, like if you know that 3 and n plus 6 is the same thing as 3n plus 18, that is the most important thing. As long as you understand how the distributive property works, you're golden. Okay, number 10. So we have this set of numbers. Which of these values can be substituted for x to make the equation true? So what that means is I am going to plug in each one of these numbers into x, into the equation to see pretty much which one it is. Okay, and it's all going to be plugged in to this x right here. All right, so let's plug in the number 1, and I'll use pink. So we have 27 minus 2. Now, this is not 2x. I can't just put a 1 here because this is not 21. What this is, though, is 2 times x. So this is 2 times 1. Actually, let me show you another way you can go about it. Let me try, oops, sorry. Let's try this. This is my original equation, 27 minus 2 times whatever x is equals 15. So now I'm just going to plug the 1 in. So maybe that helps, like if you're just plugging the 1 in. All right, so we have 27 minus 2 times 1 is 2 equals 15. Okay. 27 minus 2 is 25. Does that equal 15? No, this is not equal, so it can't be the number 1. All right, let's try the number 3. So we're going to have 27 minus 2 times whatever x is equals 15. So let me get my blue, and I'm plugging in the number 3. All right, 27 minus 2 times 3 is 6 equals 15. 27 minus 6 is 21. That's not it either. 21 does not equal 15, so it can't be the number 3. All right, this is our last shot. Let's really hope that it's number 6. It could be none. We have 27 minus 2 times whatever x is equals 15. I'm going to plug in the number 6. So we have 27 minus 2 times 6 is 12 equals 15. 27 minus 12 is 15. Perfect. There we go. So it has to be the number 6. Easy peasy. All right. This is the same problem, the same situation. We're just plugging in new numbers to see which one makes it true. So what I'm going to do is I am actually going to set up my equation replacing my variable each time. So 90 minus 2 times whatever that is. And then we have 90 minus 2 times whatever that is equals 60. Okay, so we're going to do the same thing. Okay, I'm going to try the number 7. 90 minus 2 times 7 is 14. 90 minus 14, 876. That does not equal 60. So it cannot be the number 7. So it's not A. Okay, let's try 15. 90 minus 2 times 15 is 30. Hey, 90 minus 30 is 60. So it could be, it definitely is 15. 15 checks out. Now, I'm going to show you, we don't even have to figure out what 18 is because I know it's not true. I know my answer has to be 15. Right. Number 12. An employee of a store gift wrapping box is wrapping 8 gifts, each the same size. The dimensions of the box are shown below. Find the surface area of the box. So we have to do surface area again, okay? So in surface area, all of these numbers are not the same. We can't do the same thing like we did a cube where we just found one side and had to do, you just multiplied to 6. It doesn't work that way. This box has multiple sides. So to know about surface area, I have learned that like this side, the side facing us, has the same area as the side directly across from it. And if you physically hold a box, you can think about that. The side that's facing you matches the side that is away from you. And then we have, so all I have to do is find the surface area of this front, and I will know the surface area of the back. Okay, so let's find the surface area of the front, and then we'll know the surface area of the back. So just this front portion is just this square, this portion. All right, we have just this square, sorry. So we have the area of a square is just length times width. So my length, it looks like it's 2.5 times the other side, which is 2. So 2.5 times 2, I just happen to know is 5. I do know that 2.5 times 2 is 5. So I know this whole front thing is going to take up 5 parts of wrapping paper. I'm going to add this up. This is the front. And then I know the back is another 5 as well. Cool. So we have 2 sides done, but we need the other sides. So another thing that I know is on the left-hand side, this one over here, it's the same area as the one right across from it. So let's go ahead and find the area of one side, and then we'll know the one across from it. So again, area is length times width. In this case, it's this base, which is 1.5 times this top one, which is 2. Now I do just happen to know that 1.5 times 2 is 3. Again, if you did not know that, that's fine. You can just do the math on the side. I know if I have $1.50 and $1.50, it's $3. So now we know 2 more sides. Woohoo! Now we just got to find the last 2 sides. And let's go ahead and do pink. So now we need to find the top of the box and the bottom of the box. And I know they have the same surface area. Okay, so the bottom of the box, let's do that one. It looks like it's 2.5 times this portion of the bottom is 1.5. Now this I do not know in my head. I can double, but I'm going to go ahead and do this one on the side. 2.5 times 1.5. 5 times 5 is 25. 5 times 2 is 10. Plus 2 more is 12. 0 placeholder. 1 times 5 is 5. 1 times 2 is 2. And we add them up. 5, 7, 3. And then we have to do the decimal part. And there are 2 numbers behind the decimal, so I move the decimal 2 places. All right, so now I know that it's 3.75. That's the top and the bottom. That's a lot of work. So now I just got to add up all these numbers together. Well, I'm going to go ahead and just do blue, and then we'll add these up. So I know that 5 plus 5 is 10, 13, 16. So I know I have 16 plus, I do not know what these 2 numbers are. So 3.7, oops, that's not 7. 3.75 and 3.75. Now, remember, I had to align my decimals here because we're adding now. So I aligned my decimals. I'm going to put zeros everywhere that need to be zeros. So now it's like pretty. 0 plus 5 plus 5 is 10. Then we have 14 and 15. 7, 10, 13, 2. So this would be your final surface area. Okay, do I have time for this next one? Yeah, I do. All right, the last one is talking about statistical questioning of this video, at least not the last one, we're on question 13. A statistical question is if you were to ask this question, depending on who you ask it to, you should get different answers. That's how data works. So for example, I'm going to walk up to Johnny and I'm going to say, hey, Johnny, how many hours did you sleep last night? And he'll say 8. Okay. And then I'm going to turn around and I'm going to go right up to Johnny again. Johnny, how many hours did you sleep last night? 8. Okay, I'm going to go back. Then I'm going to turn around. Hey, Johnny, how many hours did you sleep last night? And he's going to say 8. My data is not changing because I'm asking the same person the same question. I need to go to multiple people to ask this question so I can say, oh, Johnny slept 8 and Cassie slept 10 and Victoria slept 11 and things like that. That's how statistical data works. So it would have to be B, asking all of the students how they slept, not just one person.